In this video, we're going to explore domain and range in context, where we're given an input-output table in context, and we're asked to identify the domain and range in real-world terms. You see we have a table and a graph, and over here it tells us that we have a function d of p equals negative 4p plus 12,000, which gives the number of items sold when they price the items at p dollars each. So notice that that is meaning that the p is the input, the d of p is the output. The p is along the horizontal, and the d of p is along the vertical. In the graph that we're given in Excel, if you click on the Excel graph and hit the plus sign and select axes titles, it creates little text boxes on the horizontal and vertical axes, and then I can go in and edit those. Right now I know the P is along the horizontal and the D of P is along the vertical. I also, along the axes, want to go ahead and label the real-world meaning. They tell us in the problem that P, the input, represents the price per item. They tell us that the output is D of P, which represents the number of items sold at that price. Now that I've labeled my input-output axis, I can answer the question about the meaning of the horizontal and the meaning of the vertical axis. Before we find domain and range in context, you should have a sense of the domain and the range in mathematical theoretical terms. So I'll first note that the function that we're dealing with here has a domain and a range of all real numbers. The reason I know that is that when you look at this function, d of p, you can plug in any number for p, multiply that number by negative 4, then add 12,000, and you will get a real valued output. There's no number that you could plug in for p which would produce an output that's undefined, or things like square roots of negatives or division by 0. That's not possible. No matter what number you plug in, you'll be able to multiply it by negative 4, add 12,000, and get an answer out of that. So in theory, this equation has a domain and range of all real numbers. But in context, we have to break that down a little bit. We said that P represents the price per item, so you need to think about what prices make sense to plug into this function. Clearly, prices could be as small as $0, but they couldn't be negative. So the very lowest price that we could possibly include is $0. Now we got to think about the highest possible price that we could charge. Now in this case, let's take a look at the graph and the table. Right here in the table is the y-intercept, input 0, output 12,000. Correspondingly, we see that point right here on the graph, 0, 12,000. That is telling us the point where the price is free and they're selling 12,000 items. I also see in the table the x-intercept. The x-intercept is the point 3,000, 0. That corresponds with this point. At this point on the graph, we're saying if they charge $3,000 per item, then they will sell 0 items. We already said the lowest possible price they could charge is the $0 per item. That's meaning that this graph doesn't make any sense in context for values below p equals 0. These points do not make sense on the graph. These points do not make sense in the table because they don't make sense in reality. But now we know it also doesn't make sense for us to consider points beyond p equals $3,000 per item, because at those points you start to have negative items sold. If they charge $3,000, that is the point where they will sell 0 items. If they charge more than that, it would, in the function, go below the x-axis, which would mean they have negative items, and that doesn't make sense in context. So what we've learned is the lowest price they can charge is $0. The highest price they can charge is $3,000. So the domain in context is P values from 0 up to 3,000. Inclusive, you can actually have a P equals 0, a P equals 3,000, so I do use brackets. Domain is $0 items up to $3,000 items. The range is the Y values that you can get out of this, the D of P values. We see that the lowest that could be is selling 0 items. The highest that they could possibly sell is 12,000 items. So the range in context is the D of P values from 0 up to 12,000. Inclusive, you do want the brackets because they can sell 0 items, they can sell 12,000 items. The range is 0 items sold up to 12,000 items sold.